to remind us by me. Thank you.
Sure. Thank you. Thanks for the introduction, Mr. June. This presentation is a simple, straight talk. Not much of fancy, or not any, I would say, graphs or videos or any presentations of that kind. It's all simple text, English language, and straight to the point is what I would say. Basically addressing what's the need of the hour. So before that, I will probably start with a quick background being from the consultancy industry, the way we work and what we expect and the way forward. And this being a fantastic excellent platform to put forward our thoughts on what is required to be done in the industry. So that's how I have laid this presentation out. A lot of them may be not new to many of you, but still I thought it's probably prudent to go through them. I start with the simple comparison of why structural health monitoring. Generally, I mean, as we do the lot of road and rail kind of bridge inspections, what generally happens is it has to be closed and we wait for a closure to go in and inspect the bridge. That's what happens. And now with whoever is in NSW, they are aware of recent industrial actions that are happening over a period of time that we have not been able to access bridges just for that reason, because there is an industrial action, there is no power out permit. We can't get the AWP up there, so we are not able to get up close and do the inspections. So this is a major concern, and then the bridges don't get inspected at the right time. If we had some ANSHM that has been embedded in the system or installed even post-construction, that would not have been the case. When you go out to site, when you have to get up close, of course, you need a EWP, high rail, under bridge inspection unit, which again, I mean, anything that's there, I mean, that has got a risk component involved with it. Again, with ANSHM, you don't have to go out frequently to the site. It's just the first time, or maybe over a period of when there is something serious that you notice that you have to go out, and that's why the risks are minimized actually if you go use the ANSHM system. Frequency of inspection, as I said before, it's only during rail position, traffic lane closure, which is very critical. And again, that's again other safety risks with some structural health monitoring installed. It's like 24/7, 365 days. You can inspect it from the desk. You can assess the bridge as it behaves from the desk. Safety of personnel, all site-related works, post safety risks. Yesterday, I was discussing with Simon, and he just mentioned about one of the incidents that happened. There was an underbridge unit that they were on, and it was probably not fit for purpose, and it was just about to topple, and then they just escaped it. So those are the kind of risks that happen when they are out there at site. The assessment, as the conventional assessments are basically visual inspections. They are subject to human errors. I can pick up a few cracks which may not have been picked up by somebody else, or somebody else may pick up a few more cracks than what I have not picked up. So it's all based on human errors, human judgment and assessment. Whereas if we have a embedded system in the bridge or any asset, we don't have such problems. Data integrity is the next one, which is again, as I said, human interpretation. Whereas with ANSHM, we get a consistent data, we can rely on it, and that's how the bridge is behaving at its current state. And we can definitely assess the bridge based on that data. The reasons for ANSHM deployment are very easy. I mean, it's basically simple. They access the behavior of the structure in its current state. The bridges that we inspect generally are 80, 90 years old. We have few drawings, some drawings missing, or some drawings not readable. So there is a amount of judgment that goes in when we do the assessment of the bridge. So that's not a 100% accurate way of assessing the behavior of the structure. Early asset intervention and remediation, because this structural health monitoring helps us in notifying us on what the crack is, what the structure is behaving in, and based on that, we are able to kind of do an early asset intervention and do the remediation as required. Validate designs. As we know, it all starts with assumptions. We always say that concrete is a homogeneous mix. That's the very fundamental assumption we make. From there on, it starts, and nothing is actually a homogeneous mix. So there are different batches of concrete that's poured in a bridge, and they probably all have different concrete strengths and E values, which actually is subject to interpretation. You can assume that they're all the same strength. Generally, they are not. So that's to validate the design. SHM is a good way of going forward. The aim of SHM is basically to plan the optimum interventions, make the best use of resources, and extend the service life of the asset, which is simple but important. SHM methodology, when we generally do a bridge assessment, what it involves is that it starts with the desktop study of existing bridge drawings. As I said, some are available, some are not available. So again, yeah, we may start with assumptions right there. Then it's based on preliminary visual inspection. Then we model and analyze the bridge, again, based on the assumed behavior of the bridge. We assume that the bridge, as it was originally designed, is the way the bridge is behaving now. And then we load, and then we do the analysis, again, which is not 100% accurate. Then we, based on that, identify the critical members based on the analysis and initial visual inspection. And then if we are okay to go ahead with the sensor or structural health monitoring, we lay out the sensors on the bridge. We install the sensors, establish remote connectivity so that you don't have to be physically up there at the site doing the measurements. You can get it up at your desktop in your office or at the client office. Collect the data over a period of time. We have seen that this is important because just short measurements are not representative of what the bridge is. Because with the variation in temperature, for example, the bridge behaves quite differently, especially for complex structures like open span to large, for example. So the data collection over a period of time, when we go for data collection over a period of time, that involves heaps of data. Again, we have data analysts and data management, AI, machine learning, and all these things coming in to help us out with that. And once we have those, we then calibrate the bridge model, what we had originally modeled as the original design intent. We calibrate the bridge model to represent or closely represent what the existing condition or the state of the bridge is. And then based on which we do the targeted repair solutions. And then, of course, post repairs, we can still leave the monitoring on the bridge and then continue to see how effective the repair or remediation works that has been done. And of course, we can also nominate triggers for early warnings on the bridge, which is again another useful thing for the client. Now, moving on, what's the requirement? Like we see huge amount of investments on infrastructure projects. The infrastructure budget 2022-23 talks about all these millions and billions of investment in NSW by the state governments and the federal governments. But then where do this money go for? And is any or part of it involved or in the structural health monitoring? Yesterday, Simon also mentioned about this smart infrastructure policy, and he talked about the government being smart, the next elected government being smart. But what I say is, generally, I mean, all the technocrats out there are smart. It's only the resolve to implement them that's not there. Like you can see, I mean, in this infrastructure policy, you can see everything that's in line with what ANSHM is looking for. Smart infrastructure, as it is defined, bridges, hospitals, schools, because I don't limit it just to bridges, I would say any infrastructure. It could be buildings also, or critical buildings, dams, anything. It uses technology and data to optimize performance, increase capacity, and achieve greater return on investment. This is what we have been talking about the whole day yesterday. Smart technology talks about sensors, computing algorithms, all of those that we are talking since yesterday and then today also. Make better informed decisions for the customers and assets, physical assets that are embedded with processors, sensors, exactly what we are after. That's why I was telling that this is all there, but the resolve is not there to implement them. Benefits, again, all of them, what we talk about, whole of life cycle, asset management, proactively identify and predict the maintenance, operational needs, planned and preventative approaches, reduce cost, service disruptions, blah, blah, blah. Everything is outlined there. Everything is there. So there is a resolve. Somebody has put in all these things there, It's a smart way of doing it. It's done, but I don't know why it's not being implemented, and that's the need of the hour. What we think is all new infrastructure should have SHM embedded in them, because with so many billions and billions of dollars being spent on infrastructure, if you look at it as a percentage of the overall cost, this will be minuscule. So if there is SHM embedded in this new infrastructure, then what it helps it helps provide early warning for interventions, reduce risk of catastrophic failure. We are all read about this Florida pedestrian bridge, which was on 5 days there, and then over a period of time, everybody went out there. Everybody had got different opinions, because one guy said, yes, the cracks are okay, go ahead, release the stress. Another guy said the cracks are not okay. And they were discussing this, deliberating this over a period of 5 days. And at the end of 5 days, the bridge collapsed. If we had SHM embedded in them, I don't think this would have happened. We could have analyzed and found out what exactly is happening with the bridge. We would have known where the stresses are going. Is it behaving the way it has been originally designed? And we could have probably saved that. So that should not happen. If that has not to happen, then this is very important that SHM is embedded in the new infrastructure projects. As discussed previously, to help in the informed, timely, low-cost interventions instead of unplanned and delayed high-cost interventions, and minimize the need for specialist inspection and maintenance, which if you don't do it at the time, that's what is required. Ensure continued service performance. If you with regular interventions, we can even extend the life of the structure. Because more often when we are inspecting this 80, 90-year-old assets, the client has got the goal to increase the life of the structure by under 100, 120 years. That's what they're looking at. So it's already 80, 90 years old, increase it by under 120 years. So basically 200 years life. So if you want to achieve that, and that's of course a sustainable way of doing it, if you don't want to demolish a bridge or any asset and do periodic interventions and then extend the life of the structure, what more sustainability can you achieve? Structural health monitoring achieves all these goals, which are very critical. Nowadays, everybody talks about it, but this is the way to go and implement ESG, environmental, social governance, sustainability, net zero, safe. It ticks all these boxes, and these are very critical boxes to tick. So every new asset with embedded SHM is one asset less to be inspected conventionally. So if so many billions of dollars being spent, if each one of those are embedded with SHM, then it's that many assets required less kind of conventional inspections. Frees up resources for better allocation. It could be material as well as men who can probably do better things rather than just go up there and inspect. Provides more confidence in the serviceability of the structure, because it's always assumed behavior of the structure. If you know how the bridge is behaving from the SHM, definitely provides more confidence to the client, to the end user. Has less environmental impact. We have no EWPs going up there. We are no lane closures. We don't wait for train positions. So people are less impacted, less environmental impact. Provides greater level of confidence to engineers to provide optimal design solutions, because we as engineers, when we design, as I said, there are heaps of assumptions, heaps of factors to be considered based on total provisions and experience. Once we know how the bridge is behaving from what we have designed, that actually helps improve on the design and solutions. And we as, I do sit in one of the, Colin is there, myself and Peter Prasad was also there yesterday. We sit in the BD 090 committee. We know that there are some factors which could probably be better defined, and to have optimal solutions and bridges which may not be necessarily be chunky. Minimizes the redundancies in designs and standards, provides an immediate quality check on the constructed asset. As I said, sometimes the quality of the asset that is being constructed is not good. So if we have SHM embedded, we immediately know as soon as it is put into service, whether it's behaving the way it's originally intended or designed to. So we will, at the end of the day, have an embedded SHM provide a smart and sustainable asset is built. So that's how it should be. And that's why we reiterate that embedded SHM is the way to go forward and for all the future assets that are being built, if not at least what has been built till now. Thank you.
Yeah, Mahesh, I think we have some time for discussions and questions. Yeah, Colin, please.
Thank you, Janchun. Thank you, Mahesh. That's fantastic. And I'm so pleased to see the tier ones getting involved in, seeing the benefit that SHM can offer. And obviously, I think everyone in this room agrees. That's why we're here. I think we spoke yesterday about challenges, frictions against SHM. And as difficult as it may be for you to express this, how have you found selling this message, these benefits? How has that been received in AECOM and perhaps elsewhere?
Okay, we at AECOM have been trying this for 2 years, I would say. I don't want to name the client, but we approached them and we said, because we have been doing inspections for them and day in and day out, we do a lot of inspections, and we did present to them that this is the way to go forward and this is how it has to be done. Then they come back and say, has it been done before in Australia? That's the first question. Like when you come to Australia, they ask, have you got Aussie experience? It's the same thing. If you want to implement anything new, that's the first thing they ask for. And they want to look for something which is time tested and it's proven, which I don't think unless somebody implements it, and there will be, of course, it's not 100% accurate every time, the first time that you implement it. So there should be an opportunity, and it's not a huge cost, especially when you're looking at the overall scheme of things over a period of time. If you implement SHM on one bridge, maybe $100,000, $200,000, that's okay, fine. But at least it tells you, it keeps you, better informed on is that the way to go forward, or let's scrap it. We are not asking for any millions of dollars to be spent on that. Yeah, that's the initial resistance. But having said that, then we did find that we were able to convince on the client and implement them. So that's the positive side of it. I think we as ANSHM, if we are able to, push this forward and market it better, I think, and definitely it should be the way forward, and the clients will definitely accept it. It was a good presentation yesterday by Homan to kickstart on, at least to see that they have got a vision on SHM. So that's a good thing to understand. But then again, within the departments, there are different people having different aspirations, different viewpoints. So yeah, that will always be the case.
Message. Yeah,
Isn't yeah, I'm so happy to you are thinking similar as mine. I also would like to have every asset to be installed with an SHM. So that's what I align with what you think. And when you try to convince the asset owner to have this idea, normally they may ask you what additional cost you would like to have in order to have the SHM. So what will be the percentage, additional percentage of construction costs if I would like to have the new asset to be installed with the SHM?
If you ask me, based on my understanding, depending, of course, it depends on from the if you are building a cable stayed bridge or a simple super T bridge, depends on that. But I would say it will be not more than 1 or 2% that SHM will cost in the overall scheme of things. Just the bridge cost, not the project cost I'm talking about.
Yes. So we might make this in general the percentage additional cost.
Yeah, that's what I'm talking. Percentage additional cost is just 1 or 2%. But again, that if you look at it at overall the life of the structure, it will be much more cheaper, because all these interventions and all these inspections that you're doing out, if you do a life cycle assessment, this will be definitely cheaper. Initial cost will be high, but the end cost will be much lower.
on the back.
Yeah.
Hi. Can you hear me? Yeah. Yes. Yeah. It was very interesting presentation. I remember some of asset owners like ARTC. They do not accept, drone inspection on some of the large steel structures. The trusses or truss bridges. So what was your challenges with them? They need arm length inspection to those bridges.
Yes, exactly. That's what we end up doing. We go up on EWP, we get if it's on a river, we get a barge, put the EWP on the barge and then get up close and do the inspections. But that's when I think yesterday, our visit to the UTS lab on the robotics side of things, they got a fantastic robot there. And that's where I think basically those kind of things should be leveraged to, get into those kind of difficult areas and do the inspections rather than every time going up there physically to inspect the bridge.
We probably can go to the last.
Yes, I don't have a question. I just want to make a comment. Thank you, Mahesh, for excellent presentation. You have covered all aspects of SHM in a simple, easy to understand manner. So thank you.
Thanks.
Thank you so much, Mahesh, for your presentation. My question is to what extent you are utilizing technology and digitization for monitoring your structures?
Currently, if I say, probably, as I said, with number of inspections that we do, we are probably utilizing maybe 5% of technology, and the others are all still conventional ways of doing it. And that's basically because, there's no resolve from the client as well to implement the technology in the inspections.
Thank you.